All right, folks, back in action here. On this video, I want to walk through the change of base formula. A lot of us have just accepted that formula as true because we've told you it's true, but it does seem a little bit just like black magic to some students. So let's go through that proof to understand why log base a of m can be rewritten with any base we want as the log of the argument in the numerator and the log of the base in the denominator. Remembering that, in fact, this could have been written as the natural log of m over the natural log of a. Wouldn't even matter what base we choose. So this feels a little black magic to a lot of students. So let's go through that proof to get an understanding of why this is actually working. So just with all proofs, we need a place to start. So what we're going to do is we're going to start with this left-hand side of our proof, and we are just going to simply say, we're going to say let y equal our log base a of m. Now, moving back and forth between our logarithmic and our exponential forms, what I know I can immediately do is I could rewrite this initial side as its exponential form. So I could say a to the y equals m. Oftentimes the exponential form is just a little easier to see. Now, remember, one of our things that we need to think about is that a logarithm is actually a mathematical operation. So I could, for example, on this equation, I could multiply both sides of the equation by 2, or I could multiply both sides of the equation by 3, or divide them, or add something, as long as I did it to both sides. Since a logarithm is a mathematical operation, I can actually take the log of each side as well. So what I'm going to do is I'm going to take the log base b of each side of my equation. So I'm going to say log base b of a to the y, and I have to do that to the other side as well, log base b of m. Now, my logarithm rules that I have tell me that I can take this exponent here and I can write it out front as an exponent, or as a coefficient, I meant to say there, and I then can rewrite this as y times log base b of a equals log base b of m. Now, if I want to be thinking, hey, let's solve for this y here, I can divide both sides by this log base b of a. So I'll end up with y equals log base b of m divided by log base b of a. Now, since we initially defined our y value up here as the log base a of m, I can substitute one last time, and I can show then that log base a of m equals log base b of m divided by log base b of a. Now, in the course of this proof, I chose to take log base b of each side, but I could have done this exact same proof, and instead of doing log base b on each side, I could have, for example, done the natural log of each side, or I could have done the common log of each side, and I would have ended up with the exact same expression at the end, just written with a different base.